Hello and welcome to your Heats of Fusion and Heats of Solvation lab. We're going to take ice, we're going to figure out how many joules per gram it takes to melt ice. That's Heats of Fusion. Heats of Fusion is also the amount of energy released when liquid ice freezes per gram. It's joules per gram. That's how you need to be able to calculate it on your exam. All right, part 2, or task B of the lab, we're going to take ammonium chloride and we're going to put some of that in water in our calorimeter, same calorimeter, and see if that changes the temperature and by how much. We'll calculate our heats of solvation, which is the amount of energy per gram that is involved in the dissolving of a salt. Turn on your hot water for task A. We're just doing task A right now. We got to melt some ice. So get that water as hot as you possibly can. It should be about 55 degrees Celsius after a couple minutes of running. If you touch it, it should be hot, really, really hot to the touch. Once you've reached maximum temperature, you got to pre-warm your graduated cylinder and your calorimeter. We want the calorimeter and the graduated cylinder to be at the same temperature of the tap water or as close as possible so that when we put the tap water into them, the tap water doesn't lose too much energy to the graduated cylinder or the calorimeter. We want all of that energy, or as much as possible, without error, without as much error as we would otherwise, to go into the melting of the ice for task A. So get everything as hot as you possibly can. All right, now I've got my 100 milliliters of hot tap water in here, and I still have hot tap water in my calorimeter, which I'm going to dump out. That was just to keep the calorimeter warm, and put my 100 milliliters of hot tap water in my calorimeter. Put the cap on, grab your thermometer, your thermoprobe, and let's find the temperature of that water. Before you put the ice in, the temperature of the water in here should be between 45 and 50 degrees Celsius. More than that is better. Less than 45, you might want to put hot tap water in your calorimeter again. The next part is really easy. Take a couple ice cubes, drop them in, and stir. You're going to keep doing this until the water bottoms out. You want to get as close to 0 degrees Celsius as possible. If you feel like the temperature has bottomed out though, around 1 or 2, and isn't getting any lower, even with the addition of ice, then you can end it there. Here's what you don't want. You don't want to run out of ice in here. Keep adding ice until your temperature bottoms out, and keep stirring. Stir constantly. My ice was melting, so I'm going to add another ice cube and continue stirring until the temperature bottoms out. My temperature's bottomed out around 2.5 degrees. And so I'm going to take my thermoprobe out, write that temperature down, 2.5 degrees. That's your final temperature for the calorimeter. Take your ice cubes that are remaining. You never want to run out of ice cubes for this task A. You can throw those right into the sink. You want to drain them off into the water. You don't want to lose any water that's on those ice cubes. Drain that water off. All right, now you've got to get your total volume. Obviously, the tricky part here is you've got more than 100 milliliters of water in your styrofoam cup. So you're just going to fill up to 100 or around 100. Write that number down to the nearest uncertain digit. Pour that out, and then pour the rest of the water in and add. You'll have to, if you go above the 100 line, you cannot measure that volume. All of that data should be recorded here, and then you should be able to process these calculations and move on to part B, the heat of solvation. I'll show you how to do it. All right, for task B, I want you to measure out 5 grams, as close as you possibly can. Now, what's nice is that these scales go to the thousandths place, so make sure you've got 4 significant figures for your mass of ammonium chloride. I measured out 4.987 grams of ammonium chloride, so it should look approximately like that. To find the amount of energy given off or absorbed by the dissolving of 5 grams of ammonium chloride, or in my case 4.987 grams, you need 100 milliliters, or 100.0 milliliters again, using the uncertain digit, of cold tap water. Add that to your calorimeter and find your starting temperature. Now you've got your temperature 1 and you've got your mass of water. Once you have your temperature 1 and your mass of water, you can add your 5 or 4.987 grams of the ammonium chloride. Put your top on your calorimeter, continue stirring, and measure that temperature change. It's either going to go up or down. When it stops going up or stops going down, when the change has plateaued, write that final temperature down. In chemistry, as in life, change is measured by final state minus initial state. So you'll take that final temperature, subtract from that your initial temperature to get your delta T. Finally, all that waste can go down the drain today. The ammonium chloride is non-toxic, and we are going to move on to calculations. You've got all of your data here, and then you can process all of the mathematics below. Good luck today. Have fun.